All right, good morning, everybody. Today we're going to get started with day 2 of the Pythagorean Theorem, okay? So let me just spell it out right here, Pythagorean Theorem. So in the last video, we saw well, first of all, we looked at what perfect squares were, right? Numbers that you just multiply by itself. We also looked at perfect cubes, which we're not going to be utilizing until in the later videos. We also saw how we can take square roots, and that's something like the square root of 9 is equal to 3 because 3 times 3 is equal to 9. And then we used the square root and the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. If this is true, then you have a right triangle, okay? We use the Pythagorean theorem to find missing sides of a right triangle, right? Either one of the little legs, or you used it to find one of the longer legs, okay? So today we're going to be looking at special case. Well, we're not going to be looking at special cases, but we're going to be looking at decimal approximations of numbers as well as irrational and rational numbers, okay? So it's going to be slightly vocabulary heavy today, but that's fine. You're going to get a chance to practice this. Hopefully you're using IXL, okay? The school's making a big push for us to start using it, and I really like how you can actually look for a particular skill and practice it. And if you're having issues with that particular skill, we will know because you're getting it wrong. It's like Summit. We get instantaneous feedback. So anyways, let's go ahead and get started, okay? So suppose we wanted to approximate the square root of, I don't know, I'm just going to think of a random number, 23. Okay, root 23. Well, if you use a calculator, I don't have a calculator on me, unfortunately. If you use a calculator, I can tell you it's going to be 4 point something, right? Something. Now, the reason I know it's 4 point something is because since we're taking the square root, right, or the second root of 23, we're trying to think of a number such that this number times itself is equal to 23, okay? Another way to write this, square root of 23, is x squared equals 23. What number times itself equals 23? I know that 4 squared is 16, and I know that 5 squared is 25. So that makes me think that the number should fall between 4 and 5. The square root of 23 would be less than the square root of 25, which is true, and it's going to be greater than the square root of 25, and it's going to be less than the square root of 16, because this is 4, 23. These are less than or greater than symbols, by the way. And this is going to be 5. That's why I think it's 4 point something. What is that something? I don't know. I was born in the 90s, so back in the days, they actually used to have people calculate these square roots by hand. I never learned how, because by the time they sort of got rid of that standard, I didn't have to worry about it, which is fine because we have calculators, okay? So let's think about square root of 70, okay? What's the biggest perfect square that's right after 70? Okay? You're going to have to think of perfect squares, okay? So the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64. That's 8 squared. 9 times 9 is 81. 81, right? So this is going to be 9 squared. It's right after 70. And what number is before 70? That's also a perfect square. 64, right? Which is 8 squared. So the square root of 70 is going to be 8 point something, because it's bigger than 8 but less than 9. I got my puppet right here with me. Right there, P? Right? So, with that in mind, that is one way you can approximate square roots. Okay, you can do the same thing with cube roots. It's just a little bit tougher. You just have to think of what number times itself 3 times. But we're not going to do that, okay, because you have calculators. But I just want you to think, like, you know, use your brains a bit. What's the square root going to be between what 2 numbers, okay? So you're going to use the idea of a perfect square. Now, I can tell you this. The square root of 2 is equal to 1.414 dot dot dot. This number goes on forever, and there's no pattern to it. Why am I talking about this? Well, this is a special type of number, okay? Before I even reveal what its name, let's talk about, well, let's, you know, do I really want to go into this? No, I'm not. I'm going to hold myself back and we're just going to talk about what we're going to talk about. So, we have numbers that are called rational numbers, and we also have numbers that are called irrational, okay? Irrational numbers. Any number that you can think of is either rational or irrational. Any number. Okay? Any number you can think of, it's either rational or irrational. I'm looking at the time right now, it's 10:30, so let's look at 10. The number 10 is rational. Why? Because you can write it as a ratio. You can write it as 10 over 1. The number 30 is rational because you can write it as a ratio, 30 over 1. The number 20 is rational because you can write it as a ratio. It can be 20 over 1, or if you wanna feel adventurous, you can write it as 40 over 2. All of these numbers have something in common. You can write them as a ratio. The number 1.5 is also rational because you can write 1.5 as 15 divided by 10. The number square root of 2 is irrational. What this means is you cannot, I repeat, you cannot write it as a ratio of 2 numbers, 2 whole numbers specifically. Square root of 2, and that's equal to 1.41 blah blah blah. I actually don't even remember what it is, what the decimal expansion is. You cannot write it as a fraction. I guess you could say that. You can't write it as a fraction of 2 whole numbers. You just can't. It's impossible. That's what an irrational number is. It's a number that you simply cannot write it as a ratio or as a fraction of 2 whole numbers. Pi, right? Congratulations to Giovanni. Pi is 3.14159. You get the clue. This number goes on forever. There is no pattern. It is impossible to write this as a ratio of 2 whole numbers. And that is why we call it an irrational number. The decimal, 0.333333 repeating, in fact, is rational. You can write it as a fraction. This is just 1/3. Y'all kind of getting the hang of this? Numbers that can be written as a fraction, rational numbers. Numbers that you cannot write as a fraction, irrational. Usually numbers that have like a square root are irrational, as long as whatever's inside the square root is not a perfect square, right? Because, for example, this square root of 9, that actually is a rational number because the square root of 9 is equal to 3, and we know that 3 can be written as 3 over 1. So it is rational. Okay? But something like the square root of 10, that is definitely irrational. Because the square root, first of all, 10 is not a perfect square. So when you take the square root of 10, you're going to get a funky decimal. You're going to get decimals that go on forever. Okay? Now, when you look at the decimal expansion of a number, right? When you go on the calculator and you type in the square root of something or something divided by something and you get a decimal, it's really easy to tell if it's a rational number or if it's an irrational number, okay? And I'm gonna write down the rules right here so that you can also have them, okay? A rational number, when you write it as a decimal, it terminates, meaning if it ends. So something like 0.5, right? 1 divided by 2. First of all, 1 divided by 2 is half, which is a rational number. But if you convert that to a decimal to see if it is rational, it ends. It doesn't go on forever. It's just 0.5. So we know it's rational. Or if it repeats with a pattern. So if you see a pattern and you know what's going to be the next number in that sequence, it is also rational. For example, 2/3. If you do 2/3 on a calculator, it's going to be 0.6666 ... forever. You know it's always going to be a 0.66666 ... That tells you it's rational, meaning you can write it as a fraction. If it ends or if there is a pattern, it is rational. If it does not end and there is no pattern, we call that an irrational number. And look at pi, for example. That's a perfect example. The decimals never end, and there's literally no pattern. If I were to tell you the first 10 digits, would you be able to tell me the 11th? No, because there is no pattern, unless you memorize the digits. GG, Geo. If I were to make up a random decimal, okay? 0.1245978321004 ... Ask yourself, is this terminating, meaning does it end? No. Is there a pattern? I don't see a pattern. These are just random digits. If there is no pattern, it is irrational. Okay? That's actually all we have for today. It's not a lot of work. It's just I wanted to introduce this idea of rational and irrational numbers because, because it's a standard, right? Knowing the difference between irrational and rational numbers, being able to approximate numbers, right? You can sort of push yourself to put this on a number line, right? Where would square root of 70 be, for example? Is it a lot closer to 8 or is it a lot closer to 9? But knowing the differences between irrational and rational numbers, I mean, it's like day and night, you know? Can it be written as a fraction? Yes or no? Okay? So, the homework will be on Google, what's it called? Google Classroom. There's skills for you to practice on iExcel. Just remember to log in with your Google account and practice those skills so I can get some formative data so that I know what we need to work on. And it's really important that you guys, y'all are catching up on your work, okay? Because soon we're going to be having a lot of assignments, okay? Especially for review. Please be safe.